Hi, my name is Casey and I'm here to take you through a fun and engaging activity aimed at educating Year 3 children around the mathematical phenomena that is symmetry. To begin the lesson, I'm going to define symmetry by definition. In order to do that, I'm going to show the children a piece of card and ask them to identify the shape they see before them, a rectangle. I'm then going to fold the rectangle in half and ask them to again identify the shape they see before them, to which they will hopefully respond another rectangle. I'm going to then turn the rectangle over and ask them to again identify the shape. We're then going to open up the folded card and I'm going to highlight to the children that the larger rectangle is made up of two smaller equal and identical rectangles. At this point, I'll explain to the children that when an object is made up of two equal and identical parts, it is said to have symmetry. I'm going to explain to the children that symmetry doesn't just exist in shapes and coloured cardboard, but symmetry can be seen everywhere, all around us, even in nature. I'll take the children through some examples of where they can see symmetry in nature. The first example I will use is the butterfly. If we draw a line down the centre of the butterfly, we can see that the wings and the body of the butterfly on each side are a mirror image of one another. So the butterfly has symmetry. We'll then have a look at the face of the owl. If we draw a line down the centre of the face of the owl, each side is a mirror image of the other. So the face of this owl has symmetry. When an object or shape has symmetry, it is known as symmetrical. We'll explore symmetry further in the world around us and identify some more objects that are symmetrical or where we can see symmetry. I'll highlight the egg with a line down the centre. If we look at the two sides of the egg, either side of the line, they are identical. So the egg has symmetry or is symmetrical. We'll then have a look at the leaf. This particular leaf, when a line drawn down the centre, has two equal and identical signs. So this leaf has symmetry or is symmetrical. I'm going to then explain to the children that not only can we see symmetry in creatures and objects and shapes around us, but symmetry can also be seen in the human body. So we're going to have a look at the face. If we have a look at the face, the diagram of the face here, each side is a mirror image of the other. So this face is symmetrical. I'm then going to ask the children to place their hands together, joining at the pinky, the ring, the middle, the pointer and the thumbs, and line them up as perfectly as possible. I'm then going to ask the children to have a look and observe to see if all of their fingers are the same lengths or different lengths. So are they identical? I'm then going to ask the children to open up their hands and have a look to see if they can identify symmetry in their own hands. Some children will, some children won't. Depending on how that activity goes, we may then take it further and ask the children to have a look at each other's faces and see if they can identify symmetry in each other's faces. Moving on from this, in an attempt to concrete or solidify some of the learning that they have already done, I'm going to ask them to engage in a fun activity that also demonstrates where symmetry can be seen everywhere around us. So I'm going to ask the children who likes pizza. Hopefully most of them will say yes. I'm also then going to ask the children if they have ever made pizza before. And we're going to explain that today we're going to be making our own symmetry pizzas. So each child is going to be given a pizza base and a variety of toppings. The base is going to be divided by a line of symmetry, and each child is going to be asked to create a symmetrical pizza. So a pizza where each side is a mirror image of the other. The great thing about this activity is not only does it provide us a foundation for the understanding of reflective symmetry, but it provides an opportunity for us to extend beyond this learning and identify what would happen if there was more than one line of symmetry within that pizza, and what would happen if we rotated the pizza. So we could then move on to exploring rotational symmetry. That's the conclusion of my learning activity. Thank you so much for your time.